Everyone, I welcome you all for today's webinar session on Advanced Engine Technology, BS4 and BS6 technologies. I am Hitesh Kumar Dave, Assistant Professor, Mechanical Engineering Department. Would like to introduce you to today's our presenter, Mr. Yogesh Kalia. Mr. Yogesh Kalia sir is nothing but currently founder, director, and CTO of Medvi Center of Automotive Research. Mr. Yogesh Kalia, an electronic and communication engineer by profession, has been served as electronic engineering technologies since in the last 18 years in automobile industries. He is former employee of Bosch Research Team Bangalore and Siemens Research Center France. The client for Medvi Center of Automotive Research is nothing but renowned industries and institute like Mahindra, Bajaj, Eicher Motor, and IIT Madras. Sir has delivered lectures and training in renowned IITs, NITs, ARAI Pune, NIT Patiar, Chandigarh, and many more. Some of the best brain of the industry and institute in the same domain. Now, without taking much time, I will hand over the session to Mr. Yogesh Kalia sir. Yogesh sir, welcome to you.
Thank you very much, Hitesh sir. I welcome you all to this online session. My warm greetings to all the faculty members and students who are currently joined online. हितेश सर मेरी आवाज क्लियर है और मेरी स्क्रीन स्लाइड्स नजर आ रही हैं आपको?
Yes, sir, your voice is come out, but your slide is not visible currently. Kindly change it.
Slide. Okay, I will change it, sir.
Yes, sir. Now it is visible. Now you are in a first slide.
Yes, sir, I am in first slide. So
Okay.
the session today will focus on basically advanced technologies in automotive engines. So I'm sure you are all familiar with the diesel engine, petrol engine, CNG, and bikes, scooters, cars, engines are everywhere. So I will basically explain you the technologies, the advanced technologies to which are currently being used to control the engines, which is basically we will talk about electronic control units and what is BS4, BS6 and all that I will explain you in detail today. So why these technologies, which we are going to learn today, which is electronic control unit, what is the reason engines are being controlled by these technologies? What is BS4, BS6? What is emission standard? And then we will go in detail of diesel engine technologies, which is CRDI. Then we will also discuss latest technologies of petrol engine, gasoline engine. And then there is another area, after treatment, which is also part of this advanced emission control. And we will also discuss something in detail about open issues. And in the last, if there is any question, we will find out some way how students joined over Facebook live can ask questions. We will find out some way. So first of all, as a mechanical engineer or automobile engineer or electronics engineer, So engines are around since many years. So what is the reason why we have to change the technology? So something which have been running very well since years, why we are talking about now advanced technologies and this BS6 and emission reduction and so on. So the reason is, first of all, there is a global focus on environment sustainability. Uh, if you, I'm sure you are all well aware about COP26, where all governments have committed to reduce the emission, and also we are talking about net zero, where every country has pledged to the global community that each country will make efforts to have net zero emission. And this is the international scenario, and then based on this, government further delegates these targets to industry, and automotive is a low hanging fruit. I would say they are the first ones, or they are the first ones to receive the target. So this government uh, skipped Bharat Stage 5 and directly jumped to Bharat Stage 6. I will I will explain you what is BS6, and then there is also a lot of problem in Delhi time and again. Pollution is reaching to unacceptable levels, and we have to stop the vehicles. And also, in even today in Delhi, no power generators are allowed to run on diesel. So Supreme Court has banned. Uh, so what I want to explain you is there is a global effort. There is a level at top level in India to reduce the emission. What is coming out of these vehicles? So that is why the technology which is responsible to control these parameters, which actually are directly affecting the emission and performance of engine, must be upgraded to meet these government targets. That is why whatever we are talking about BS4, BS6, this is the reason, because government is making the targets stringent day by day. And if you can, if you are if you are regularly, uh, reading the right kind of news, you will know that now government is talking about biofuel engines, ethanol. Our minister wants vehicle to run on ethanol, which is a biofuel generated out of sugarcane, and also I think a lot of focus in natural gas. In especially Gujarat is leading the charge in natural gas, which is methane, and we are now talking about bio CNG. And another fuel which is coming up is LNG, liquefied natural gas. This is also quite famous, and a lot of companies in Gujarat are aggressively working in these alternate fuels. So, all these government policies, government push, and customer, when this applies to this, whether it is two-wheeler or passenger car, or it is say load carrier, trucks, tractors, or power generators, or off-highway vehicles like cranes, hydraulic cranes, and also like combine harvester combine. So all of these vehicle segments are affected by these changing requirements. So one thing is very clear: whatever mechanical systems which have been uh, working in the past to control these engines are not good enough. So we need advanced technologies like petrol engine, electronic fuel injection, CRDI technology, and then there is gasoline direct injection and DPF and SCR. So there are so many advanced technologies to meet these stringent targets. So we will go into the details of these technologies, technical details. Okay. So first of all, emission standards. Before I take you into the depth of technologies to meet Bharat Stage 6, let us understand what is actually an emission standard and what do we mean by this. Okay, Hitesh sir, I think I'm well audible.
Yes, sir, you are audible.
Okay,
Yes,
okay,
sir, you are audible. Continue.
right, sir. Thank you. So emission standards are the requirements that set specific limits. So any vehicle, any two-wheeler generator, anything which has engine when it is running. So government has put specific limits to the amount of pollutants that can be released into the environment. So it's not that just any car can be sold and run on the roads. So government has very strict rules. So typically the gases which are regulated are hydrocarbons, carbon monoxide, and nitrogen oxides, which is NO and NO2, NOx. It is called particulate matter, and then also carbon dioxide. And in some cases, in gaseous fuels, it is also NMHC, which is non-methane hydrocarbons, and so on. What I want to say is any vehicle which is sold must meet certain emission criteria, like you students or the faculty members. You are aware anybody to become engineer, you must score certain grades, certain CGPA, certain percentage marks. Only then you are awarded engineering or PhD degree. So similarly, for any car or any vehicle to be sold, there is a similar passing criteria, which is basically called emission standards. So, and who prepares it? It is instituted by Government of India, and they are mainly based on European regulations, and they were first introduced in 2000, and now they started with Bharat Stage 1 on, you can see on your screen on the right hand side. Just to give you some idea that BS1 means there was a pollution target, but it was quite relaxed, and with time, with the progression of time since 2000, BS2, BS3, BS4, and slowly you can see now we are at BS6, and you can compare the amount of pollution just for the reference. You can compare BS6, you are not allowed to have a lot of pollution, so engine must have very, very low emission. And there are, like you students, you have universities to do all these regulations. So government has regulatory bodies, and these are laboratories. It is like an examination center for you students. So vehicles are tested, and then emission is measured. They are driven in a particular cycle, and then whatever smoke or pollution, harmful gases are coming out of the engine goes into these machines, and then as per the target they are compared. If you are pass, you are given a certificate. If you do not pass, then you are expected to make technical changes so that you can meet the emission targets. So this is how it works. And just to put some numbers on the screen, if you can see the if you can see the if you can see the this one, can you see 4.7 is Hc plus NOx, and 0.04 is the particulate matter. It is for tractor application in India. And you can see the next target. You can see this 4.7 will come to 0.4, and this zero point 0.4 will become 0.025. So you can see the difference. This is, you can see NOx plus Hc and PM. So which is very clear that to go from one level to the next level, there is significant reduction from, for in NOx plus Hc it is 4.7 to 0.4, and particulate matter, which is actually smoke, uh, from 0.4 to 0.025 is more than 90% reduction. You can see yourself, which is a lot. Okay, so now how do you, as an engineer working on engines, how do you bring such a reduction in engine emission? It's a question. The answer is, for diesel engine, you can see the old technology, inline pump and rotary pump, is now replaced by advanced ECRDI systems, common rail direct injection, which we will learn in detail. And for petrol, we will have carburetor and spark distributor, and nowadays replaced by MPFI and electronic fuel injection technologies. And similarly, brakes and other systems are also changing. So the summary, why as a young engineer, as a student studying mechanical, automobile, electronics, etc., or computer science or whatever, uh, what is the message is clear, that in cars most of the innovation will come from electronics. So all new features, all new gadgets, all new emission control devices will be somehow controlled by electronic systems. Emission regulations, safety requirements, so you will have more and more electronic systems. So you know, it is a opportunity for the universities, so to equip your students with this latest technology knowledge, so that they can handle the industry requirement from the day one. So my organization, which is Medhavi Center for Automotive Research, written on your screens, and this is our knowledge, how we can combine electronics and engines, and how we can meet the government stringent emission norms is our core knowledge. We started operations in 2010, and that's our area, CRGI, GDI, and so on. And we work with, I think Hitesh sir mentioned this to you, we work with industry as well as top institutes in India. I think in Gujarat, we are working with IIT RAM, IIT RAM, and also, if I can recall, I think NIT Surat as well. So we have international tie-ups as well, because this technology is very complicated. The electronic systems to for engines. So we have some technology partnership, some development we do in Sweden, and that's how it is. Now I will come to the first technical topic, wherein I will explain you the CRDI technology, diesel engine technology, that how an electronic system based fuel system, which is actually CRDI system, how it can be used and how it works, and how this technology works. Electronic, it is also called electronic diesel control, CRDI technology. So the full form is a common rail direct injection. Common rail because you have a. It is also very important question. So why it is called common rail? Because this pipe, can you see, is a common rail, which is like a accumulator where diesel is pressurized and stored, and this pressure is regulated. I will explain you. And these injectors, if you see carefully, are responsible to inject the diesel. This one, two, three. So these injectors are responsible to deliver the diesel directly into the combustion chamber, right on the top of the piston. When the piston is moving towards TDC in compression stroke, so these injectors will inject the diesel at very high pressure. So that's why it's called common rail and direct injection. And EDC, electronic diesel control, because there is an electronic system involved which controls diesel system. So that's why it is called electronic diesel control as well. हितेश सर, आई होप मैं ज्यादा स्लो या फास्ट नहीं हूँ.
नहीं सर, बराबर है, कंटिन्यू.
ओके. सो इलेक्ट्रॉनिक डीजल कंट्रोल, CRDI is everywhere. You take Nissan Micra, it is called DCI. Maruti Swift diesel, Artiga, or any diesel from Maruti, you will find a word DDIS. General Motors, you will find TCDI. Mahindra, any vehicle, you will find CRDE. Ford, Figo, TDCI. Tata vehicles, you will find Dicor, and in the end, you will find Hyundai vehicles with words CRDI, and there are so many other words like CDI on Mercedes Benz. You will find DDIS and D4D on Toyota vehicles, and so on. So each company may have a different acronym, different word, but in the end, all means the same, that the engine is CRDI technology control, where an electronic control unit is doing all the control work. So ECU, what is the work of an ECU? Before that, let us, I think you all know engines very well. Diesel engine, four-stroke, suction stroke, air enters, compression stroke, whatever air has entered is compressed, and when the piston is moving towards TDC, diesel is injected at high pressure so that diesel gets atomized and it gets mixed with the air, and due to high temperature and pressure reached due to compression, the diesel gets ignited. That's why it is called compression ignition engine, and you will get a sudden increase in pressure, which will give you torque at the flywheel end. And this is the most important, one of the most important stroke, which is power stroke. And in the last stroke, you have all the gases going out into the exhaust line or the environment. So something which is affecting the combustion, if you look at it very carefully, where you are getting the torque and also combustion is happening, is if I may ask your understanding, it's basically how much diesel you inject, the diesel quantity, the pressure at which you inject the diesel, And also another important aspect is the timing, the injection timing. It is also called very technically SOI, which is start of injection. So, which means if we want to control this combustion and reduce the pollution, we must control this combustion in a very, very precise and accurate manner. So, we need ECU. I will explain you. In a mechanical system, this combustion where fuel is going is mechanically controlled, and there is a spring and there is a cam lobe and so on. But in an electronic diesel control vehicle, which you know, CRDI, when the driver presses the pedal, no mechanical linkage is controlling the fuel. In a mechanical system, when driver is pressing the pedal, driver is directly controlling the fuel mechanically through some linkage, some levers, some springs, some camshaft. But in an electronic diesel control, this request goes to ECU, which also receives a lot of signals from sensors, and ECU will do all the calculations. It has got softwares, algorithms, and ECU will then give command to injectors, and fuel is controlled and injected into the engine. So summary is, in a mechanical system, the combustion process or the fuel parameters are mechanically controlled, but in an electronic system, the fuel parameters, the like injection timing, pressure, etc., are controlled electronically based on the signals received from the driver demand and sensors. So this is the big difference between mechanical system and electronic diesel control. So anybody may ask, what is the advantage? Advantage is, in a mechanical system, you can see there is no fuel quantity correction or combustion optimization. If the load is changing, if speed is changing, if environment is changing, temperatures are changing. But in an electronic diesel control, you can see the sensors which are sending so many signals to the ECU, like what is the altitude? Are you in Ahmedabad or are you in Manali? Is it hot? Is it summer or is it winter? So okay, I think did you lost the screen?
Now, sir, we get it again.
Okay, you got it again. Okay. So I was explaining you, an electronic diesel control has information of the vehicle, of the environment, of the engine speed, of the load through sensors. You can see this slide. There are a lot of sensors like crank position, atmospheric pressure, boost pressure, fuel temperature, inlet temperature, coolant temperature. So a lot of information is available to the ECU, and ECU has very, very advanced software algorithms by which, and data by which ECU can then calculate and control the output parameters like fuel, airflow, glow plugs, EGR, fuel pressure, etc. So this is a CRDI system, common rail direct injection, where sensors will give signal to ECU, and ECU will give then command to the pump, and pump will generate the pressure in the common rail. You can see on your screens, and ECU will regulate this pressure, and this pressure varies from around 250 bar, it can go up to 1600 bar, or in some cases it can also go up to 2500 bar. And ECU will also give command to injectors based on the firing order and also the injection angle. And the ECU can also split the injection, so which is called pilot injection, main injection, and post injection. So ECU has a lot of advanced features uh, to control the fuel. So this is how the fuel system looks like in a vehicle. I will explain you the flow diagram. Um, this is how you will find. So you start with the fuel tank, and there is a fuel pump, electrical fuel pump, and then fuel goes to filter number two, and this is a high pressure pump which will pressurize this diesel and send it to rail. You can see this red line. These red lines you can see is basically high pressure, and these yellow lines means low pressure, around 1 bar, 2 bar, or maximum 2.5 bar. And this red line means you can go up to 1600 bar. And the same diesel is supplied to the injector. You can see a lot of sensors and ECU will control these parameters. And you can also see there is a return line, this line, and there is a return from the rail, there is a return from injector, and it goes back to the tank. If you want to see this line, you can see this is going back to the tank, and then ECU is basically is the brain of the entire engine, receiving signals and then doing the control work. So what is the advantage to the end customer is if you have a normal mechanical system based on the environment conditions, no engine control will change. You have the same controls, but in an ECU based vehicle, you have the combustion always being corrected to optimized level based on the sensors. Okay, so that was all on the diesel engine, how we can meet advanced emission norms, how we can control the combustion. And this is our Facebook page. If you want more of this information, you can also like this page. All right, so I'm moving to the next technology, which is also a diesel engine technology. It is in particular it is only one slide. It is basically SCR, which is selective catalytic reduction. So what happens in selective catalytic reduction in this is actually used on the gases which are coming out of engine. It is called engine out emission. And even after deploying the CRDA technology, if you cannot meet the government targets, so what is the next step? Whatever is coming out of engine, the gases must be treated chemically before they are released into the environment. You can see that this is called SCR system, selective catalytic reduction, and this is very important, this chemical reaction, because what we are doing is we are using a urea tank, you can see, and this is a ECU, and this is a urea dosing valve. So what it does is it mix the urea, it injects the urea into the exhaust line. There is a catalyst, because for any chemical reaction to happen you need a catalyst which will not participate in the chemical reaction, but you need the catalyst to speed up the chemical reaction. So this is a chemical reaction which is happening, which is in the exhaust line, controlled by the ECU. Okay, so here is the chemical reaction NO plus NO2. Okay, I will just yeah. This is a chemical reaction. You can see nitrogen and nitrogen dioxide. I think I explained you. It is coming from engine out. You can see here, and then it reacts with decomposed ammonia, which is NH3, and ultimately they react and forms nitrogen and water. Both are not harmful. So this is how an electronic control unit sitting in your exhaust line is injecting urea into the exhaust to control the emission. Okay, then there is another technology. It is a very advanced filter, DPF filter, and uh, it is sitting in the exhaust line. So the job of this is to filter out the particulate matter, the smoke, and it is the challenge is to there are very high temperatures. Sometimes it can go up to 700 800 degrees centigrade. So the material must be able to withstand that. So normally we use silicon or silica carbide, SiC it is called. And the another challenge is if you use it for around 10,000 kilometer or so, it gets choked like any filter, which must be cleaned. So there is a process called, I think you can read on your screen, the filter. There's a point number 2. Filter will become choked or restricted and needs to be cleaned, or it is called regeneration. So there is a computer, there is an ECU which will inject diesel into the exhaust line, and it will raise the temperature of exhaust so that the accumulated PM can be burnt off. So this is a process which is happening on board your vehicle, and probably you will not even know that. This is how the ECU will control the regeneration. Okay, now I'm now moving towards the petrol engines, because it is not only diesel engine which is getting equipped with latest BS6 technologies. Even now you will see all the two-wheelers, bikes are also upgraded to a technology. It is called electronic fuel injection, where you will see no carburetor. Carburetor have been replaced by an ECU, electronic control unit. So the only thing different between petrol and diesel engine is, I think you may be well aware that in petrol engine, air and fuel as a mixture goes into the combustion chamber. It is compressed and ignited by a spark plug. So this is a big difference. So in diesel engine, it's only the air and mixer is ignited by compression. But in gasoline engine, petrol engine, air fuel mixer goes and is ignited by spark plug. So what an ECU must do in a petrol engine is petrol engine is uh, there is an injector. There is an injector which is injecting the fuel into intake manifold, and the ECU will give command to the injector. So ECU will receive signals from a lot of sensors like throttle position sensor, engine speed, oil temperature, and manifold air. And based on that, ECU will calculate, similar to diesel, what is the best air fuel ratio, because in petrol engines we control air fuel ratio of the mixture which goes into the combustion chamber. And you can see in an electronic fuel injection there is no carburetor. And also the spark timing is also controlled by ECU. And in the latest technology EFI systems, even the throttle is also electronic throttle module, which is ECU controlled, which is called drive by wire, because there is no mechanical linkage. We are actually driving through electrical wires. This is EFI system, and this is how you will find the your two-wheeler, your bike these days. There is an ECU sitting in your vehicle. There is another advanced technology called gasoline direct injection, which is super advanced. And the difference is, in an electronic fuel injection, the fuel is injected into the intake manifold, but in the GDI, I think very clear from the name itself that gasoline, which is petrol, is injected directly into the combustion chamber. You can see this, I think, system layout drawing as well. You can see this. The gasoline is being directly injected into the combustion chamber, and the pressure is also very high as compared to EFI. So how it all started, I think we started with carburetors way back in 60s or 70s or even before that. And and then we switched to MPFI. To my knowledge, I think India, Maruti 800 was launched in year 2002 or so, but globally it started way before that. And GDI, I think it was around 2015 or 14 or so. First GDI vehicle was launched in India, and today you have many GDI vehicles. You have many GDI vehicles in market, gasoline direct injection. They are also called. They are normally turbo, also turbo petrol. So